We got a lot to cover today, so let's just go ahead and get started. So thank you everyone for coming to my session. Today we're going to be talking about how to automatically or automate publishing your PowerShell modules. My name is Daniel Schroeder, and before we get into it, I just want to take a moment to thank the sponsors for putting the PowerShell DevOps Summit on. So without these guys, none of us would be here. We wouldn't all be able to come together, meet with one another, learn, have great times. So big thank you to the sponsors for allowing Summit to happen. If it didn't, I think we'd all be pretty sad. So I also want to give a quick shout out and thank you to my employer, IQ Metrics. I've been with them for about 15 years now. They are a great company to work for. Their purpose or their motto is creating great experiences, so not only for our end users and our customers, but also for employees. And so them supporting me in being able to come here and speak with you and attend the conference is just one way that they help create a great experience for myself. So thank you to them. Okay, so a little bit about myself. Again, my name's Daniel Schroeder. My online alias is Deadly Dog, pretty much everywhere. So you can find me on Twitter or GitHub. Mastodon is just @DeadlyDog. You can also find me on LinkedIn. So I've been a software developer for close to 25 years now. Sort of the past 5 years, I've had more of a focus on DevOps, like pipelines, that type of thing. So yeah, been a software developer for a long time. I've been blogging for over a decade. And what I'm really passionate about is making tools to improve developer experiences. So I love automating things. I love creating developer productivity tools. Hence sort of why I'm giving this session, right? Automating publishing your modules. That's something that developers do. If you write code, I consider you a developer. So you might say, I'm not a developer, I'm an ops person. You're writing code, it's developing. Right? So yeah, let's go ahead and dive into it. So today, before we talk about automating publishing of our modules, we might want to talk about why do we even use modules to begin with? Why would we want them? Why not just use scripts? So after that, we're going to talk about why you would want to automate it. What's wrong with manually publishing it? And then look at different ways to automate the publishing of our modules. From there, I'll just give a demo and a quick wrap up, and then take any questions if there's time at the end. Okay, so why do we even want to use modules? Like, what's wrong with just using a script? So this slide, this topic alone could probably be an entire session, but for me personally, it boils down to 3 things. Modules are easy to install, they're easy to update, and they're easy to use. And so if you compare this to, say, using a script, if someone said, hey, yeah, just go grab my script and start using it, you probably have a bunch of questions that come to mind, like, well, where do I get your script from? Is it in some GitHub repository somewhere? Maybe it's a GitHub gist. Maybe it's stored on some file share that I need to access. Maybe it's on a management server. Like, how do I get that script onto my local machine? If you're using a module, it's just one command, right? Install module, name of the module, it'll go grab it and install it on your local machine. Easy. Along the same vein, they are easy to update. So again, if you're using a script and you've copied it from somewhere else to your local machine, you're always wondering, am I using the latest version of the script, right? So you'll have to go check wherever you got it from. Like, if they put a version number at the top in the comments, you're lucky, and you can just say, oh, they're on v1.3, I'm still using v1.2, I'll copy it across. But a lot of the times you don't have that, and you actually have to look at the file contents or the script contents to see, does it really match, right? And copy it to your local machine. So again, modules eliminates that whole problem. Just run update module, and you're guaranteed to have the latest version. And then also, they're easy to use. If you're using a script, it's going to be on a file on your local machine somewhere, and if you want to invoke it, you have to know the file path to the script, right? So now I have to know where this script is stored all the time. Modules, you don't have that problem. You just run the commandlet name, and it's going to work. Okay, so how do we get to using modules? So first off, I'm going to say not everything needs to be a module. Scripts are fine. They do have their place. And so if we just maybe take an example of maybe your manager asks you, hey, if we want to retrieve all of the information for the app services in this subscription, in our Azure subscription, and generate a nice report for me. So you say, okay, So probably the first thing you're going to do is just start messing around in the terminal, right? Querying, maybe you're using the AZ module, or you're going to go look up the documentation and the REST APIs, and just start playing around in the terminal, figuring out how can I get the information out of Azure. So, maybe you've got it nailed down to, well, okay, I need to run these 5 or 10 commands to get the information I'm after. So you're probably going to go ahead and put that into a script next, so you're not constantly having to type that out all the time. And so, you run the script, you get the report, you give it to your manager. And now he comes back to you and says, okay, that's great, this report is awesome. I want it now for this other subscription, this other Azure subscription. Can you run it again? And so if he hadn't asked you to do that, maybe it really was just a one-time thing, that's where you could just leave it. You would just have this script, and it's almost a throwaway script, you're done with it, you might never run it again. But if he has come back to you and asked you, can you run it again for this other subscription? You probably maybe have the subscription ID in like a variable at the top of your script. So your first instinct might be, well, let's just go slap the other subscription ID in that variable and run my script again. But he might ask you to do this every week or for a whole bunch of different subscriptions, right? And so the next evolution in your script would be, okay, let's get rid of that as just like a script level variable. Let's move that up to be a script parameter. And so now I don't have to constantly be changing the script contents. I can just pass in a different Azure subscription to my script. And the actual script itself never needs to change. And so if you only have to run this thing once every 6 months or once a year, or you're the only one who ever runs it, this might be perfectly fine. Now you have a script, it takes the subscription as a parameter, all is well and good in the world. But if you all of a sudden find like your teammates want to be able to run this script, or you want to share it with other people, even outside of your team, that's when it becomes a really good candidate for turning it into a module, because it makes it really easy to share with other people on your team, outside your team. It's easy to ensure they always have the latest version. And so that's typically when you want to take your scripts and turn them into a module. So turning your script into a module is pretty trivial. You change the file name from PS1 to PSM1, right? Add a PSD1 manifest. There's not a whole lot to it. I'm not going to cover that here. But yeah. So creating the module or turning it into a module is easy. Publishing it is easy too. So show of hands, who here has published a module before? Okay, so about half of the room. How many of you just use this command, publish module? How many of you type that into the terminal to publish your module every time? Okay, a couple hands, a few hands, yeah. And so it's easy, right? It's just one command. You provide the path to your module directory, your PowerShell gallery API key, or maybe it's an internal gallery feed. And so it's easy. So what's the problem, right? So let's say you've published your module, and now V1 is up and out there. And so now you're like, oh, I should make some changes to my module. You go and do some updates. You run this publish module command again. And what do you think happens? It fails, because you forgot to bump the version number. You can't publish v1.0.0 twice. It'll say v1.0.0 already exists. You need to change the version number, right? And so you're like, okay, that's easy enough to do. It's one extra step. I can remember to do that. So you go ahead and do that. So then you publish another new version of your module, and the next day somebody files a bug report saying, I've been running your module, it was working fine, but today, just now, this thing is broken. And you think to yourself, I know I wrote a pester test for this exact use case. Why? It shouldn't be, it should be working fine. And then you remember, oh, right, I've got to actually run my tests before I published the new version of my module. Right, so yeah, so you're like, facepalm, what am I doing? Okay, that's only two things I can remember to do that. Bump the version number, run the tests. And then so maybe the next day you have a teammate comes to you and says, I've made changes to the module, I want to publish them myself. And you say, okay, well go ahead and run the publish command. And they're like, well, I can't, I need the API key. You're like, oh, right, I guess only I have that. And so now you're gonna end up sharing your API key among the team. So worst case scenario, you're passing that secret around in plain text over like email or Slack. Best case scenario, you've put it in like Azure Key Vault or LastPass, some sort of password manager, right? And then your team members all have access to it. But I guarantee if they're publishing the module frequently, like 2, 3, 4 times a week, they are not going to go to Key Vault every time to get that API key. They're just going to throw it in a plain text file on their local machine. Yeah, your security team will not be happy. So, and please, please, please do not store the API key in source control. That's the worst thing you could do. Okay, so now we have other people wanting to deploy the module as well. So you think, okay, it's not just myself. It's time to write some deployment instructions. And so, you go ahead and in the README file, maybe in your Git repository, you have your steps. Okay, step 1, bump the version number. Step 2, run the tests. Step 3, go get the API key from Key Vault. And so the problem with instructions, though, is it's all manual, right? Someone has to read those instructions, and you have to hope they interpret them in the same way that you intended, and that's not always the case. People are human. We make mistakes. Someone might just glaze right over a step and not do it at all. Maybe after publishing the module 3 times, they just think, I know the process, and they stop looking at the deployment instructions. Even though you might keep adding steps to it, they don't go back to look at the instructions, so they don't know about that. Okay. So now you have some instructions that people can follow. That's great. Your manager comes to you and says, the new version of the module is great, but the documentation is all out of date. So you're like, okay, that's a good point. We should add that to our list of things to do every time we publish a module. So you add that to your deployment instructions. And while we're at it, since we have documentation, we should probably be running spell check against that. So if your PowerShell module is open source, or maybe it's available to both internal and external customers, you want it to look professional. You don't want a bunch of typos. Maybe you want to filter out curse words, that type of thing. And so you're like, okay, one more thing to add to our deployment checklist, right? Okay, so next, maybe the next day your manager comes to you and says, oh, the PowerShell module was working great yesterday, but I ran it today and it's just totally broken. And you're like, well, why would that be? We haven't published a new version today. Like, we haven't published one in a week. And it turns out maybe someone from a different team found your deployment instructions. And they're like, oh, well, I'm just going to go ahead and make this change to the module that I need, and I'm going to push out a new version, right? So like, we don't want that happening. So now you have to worry about restricting access. Who can access that API key? So only certain people can actually publish your module. So yeah. And so your manager says, well, we really want to prevent this from happening again, right? So we should probably set up some notifications. So every time we push out a new version of the module, I want this Slack channel to be notified. I want this email distribution group to get notified. And so you're like, okay, this list of things we need to do every time we publish a module is getting pretty long, but let's just add it. It's one more thing. And then again, maybe the next week, someone comes to you and says, everything was working great in the PowerShell module until version 1.3.2. I downloaded that version, and now things are broken. You're like, well, that's great. I have a version number. So you go back into your Git history, and you're trying to figure out which commit actually corresponds to version 1.3.2. I don't know. I know the date that the module was published, but there's 20 different commits happened that day. And so you want to tag your Git commits with the version number to make it easy to tell this is the exact commit that was published. Okay, so now our deployment checklist is really long. And so you think, well, you know what? I know PowerShell. The checklists, I love. Like, I do personally love checklists, because whenever I see a checklist, it basically is just something that I can automate away, right? I have these 10 steps that I have to do manually all the time. I don't want to do that. Let's just turn it into a PowerShell script. And so that's definitely a step in the right direction. So maybe I'll just pause here and ask, I'll pause here and ask, so how many people who are publishing their modules actually use a script? So instead of manually typing publish module, you have a script that you run on your local machine to publish a module. Okay, 2 people? A couple people, yeah. So this is good. It's a step in the right direction. But not everything can be automated and enforced through a script, or it doesn't necessarily lead us to the best practices. So what I want to talk about in the next few slides here is how we can make it even better by utilizing pipelines. And so when I say pipelines, Azure DevOps calls them pipelines. In GitHub, they're called actions or workflows. So for the context of this talk, if I say pipelines or actions or workflows, they're all the same thing. Okay, so if we're going to use pipelines, again, it enforces good practices. So it forces us to use source control. I can't run anything from a pipeline if the code's not in source control. If I was just using a script on my local machine to do a publish, I wouldn't have to use source control necessarily. I could just publish away, right? And just a quick aside, just from talking to people, a lot of the times their biggest reluctancy to using source control is like, it's a lot of extra overhead. I have to go create a new Git repository, like add a README, all this stuff, right? But if you're just creating a whole bunch of scripts, even if you're not creating modules, even if you're just creating scripts, please use source control. You don't need a separate repository for every script you write. Just have a dumping ground repository. And whenever you create a new, or like a playground repository, whenever you create a new script, just check it in there. Because you never know, you might think, I'm just gonna use this thing this one time. But then 6 months later, you're like, I need to do a similar task. I wish I still had that script I wrote a long time ago. Or you're talking to a coworker, and you're like, you know what, I did something similar. You can go look at this script I wrote as an example. So yeah, source control should be table stakes for everything you write. Please use it. If we're using pipelines as well, we have our code in source control. It also means you can enforce other good practices like doing code reviews. So you can say you're no longer allowed to check in directly to the main branch. All changes have to come in through a pull request, and all pull requests have to be reviewed. So you might not want this on like every module that you create, but definitely the more critical ones. If it's just like a personal one where you're the only person using it, you don't have to do this. But using pipelines enables this type of thing, right? And so another good practice it enforces is even if you are using source control, it sort of forces you to push all your changes off of your local machine back up into like GitHub or Azure DevOps. Because what happens if you've released 3 new versions of your module, but you actually haven't pushed any of that code back up to GitHub, and then your hard drive dies, right? Then you've lost how much work. Or maybe your coworker wants to contribute to the module, but the one that's actually up in GitHub is 15 commits behind. So it forces you to push your code up as well. So that's an excellent practice. It forces you to publish from the main branch. So who here has accidentally committed code to the wrong branch? Like maybe you committed to main instead of your feature branch that you thought you were on, right? Happens to us all. It's super easy to do. And you can make the same mistake if you're running a script to publish your module on your local machine. You might accidentally publish from a feature branch instead of the main branch. Using pipelines also allows us to get approvals. So maybe you need your tech lead or your team lead to approve it before it's allowed to go out, or your security team or your change management team. If you're running a script on your local machine, you can't really get them to approve it. The best you can have is like a prompt. Did you check with the security team? Yes, no. And even if I haven't, I'm just gonna say, yeah, I did, and push out my change, right? Deployment schedules. You guys might have a policy where you're only allowed to push changes out in the evenings, right? Or maybe only on Tuesdays and Thursdays. If I'm just running a script on my local machine, I can push it out anytime I want. Even if you write some code to say, is it Friday afternoon? I can just go modify my computer's local time to say, yeah, it's Friday afternoon, and I can push it out whenever, right? Baking new versions. So especially for mission critical things, you might want to just release a pre-release version of your module and sort of let that bake. So your company might have 10 different systems or components that reference your PowerShell module. And so maybe 2 of them use the pre-release version, and the other 8 use the stable version. And so you might want to say, okay, we're going to release the pre-release version. We have to wait at least 48 hours before we publish the stable version. That gives those 2 systems that are using it time to make sure there's no problems with it. And if there is an issue, then we can just go and cancel that pipeline. If there are no issues, then the pipeline will just pick up automatically in 48 hours and push out the stable version. And finally, compliance. So you don't want to run into an office space movie situation where you start maybe skimming pennies off of every transaction and funneling them into your own personal bank account. Or maybe you do. You don't want your coworker to do that. And that can easily happen if the people writing the code are also the people deploying. So this is more for things like PCI compliance and things like that. They have these strict requirements. Most modules may not have this, but if you use pipelines, it allows for that. Okay, so we've gone over a whole bunch of things about why you would want to use a pipeline, and basically, like the end result is it creates a pit of success. So if you have a new employee coming into your team, you want things to be easy for them. You don't want to have to tell them, hey, go read these 20-point instructions and follow them, because they're going to do things manually, they're going to make mistakes. Similarly, you don't want to say, hey, yeah, there's a PowerShell script to do this, just go run it. They're probably going to open it up, run it, and they're going to get errors because they don't have all the dependencies and all the modules installed, right? It makes it very hard for them. If you are able to just tell them, hey, go to this website and click the button to do the deployment, it's easy. They can't screw it up, right? So you want to create a pit of success, just so make it very hard to do the wrong thing. Okay, so pipelines. Yeah, why they're awesome. It eliminates the it works on my machine problem, right? Because if you're publishing from your local machine, it might work for you, but not for your coworker. You no longer have that problem. So it encourages consistency and repeatability for all your deployments. You get logging for free. So you can just go to the GitHub Actions website and see the script that ran, all the output that it produced. If you run into an error or a problem, you can just share the link with your coworker. And then they can go look at it, they can debug it, they can fix it. You don't have to worry about copying the output from your local machine and sharing it with them. Security, that API key that we were talking about that you had to store in Key Vault and like share amongst your coworkers or control who had access to it, now nobody has access to it. The only thing that has access to it is the pipeline, right? So it's more secure. You get auditing. So this is being able to tell who actually published the module, because if we're running it from our local laptop with a script, it could have been anybody on our team or someone from a different team. If we're doing it from a pipeline, it records, who actually kicked off this workflow, who did it. And finally, notifications. So a lot of CI/CD systems like Azure DevOps allows for subscribing to notifications. So instead of you having to write it into your pipeline, hey, go send a message to this Slack channel or to this distribution group, people can actually just go up and subscribe to those themselves. They can say, hey, when there's a deployment of this pipeline, notify me, send me an email. So they can self-serve on those subscriptions. And same thing with setting up Slack channels, right? So you can take that outside of your pipeline and people can subscribe. Okay, so who here has actually created a deployment pipeline before? Yeah, see about half the room. Yeah, so you've probably ran into this problem when testing your pipelines, where you make one commit, another commit, you just commit, you're just trying to get this thing to work, right? It just keeps failing, and that can be very frustrating. So we want to avoid that, and that's what I'm just gonna demo here right now is there's a new module, there's also a GitHub repository, and so yeah, let's take a look at how to do that. So here's the URL for anyone who wants it. This is my GitHub, it's PowerShell.script module repository template. And why are you not? There we go, okay. Yeah, so here's the Git repository. And so if you scroll down, you'll see it just says talks about what it is, the features it provides, but we're gonna jump right into the getting started section. So there's two ways you can use this. Number one is it comes as a PowerShell module that you can install and just use that to create your repos for you. You can also just use it as a GitHub template. So let's take a look at both of those examples. So if we want to use the PowerShell module, the very first step here is just install module, name script module repository template. It's a bit of a mouthful, I know, but it's very descriptive, at least it's obvious what it does. And then if we want to create our new repo, we're just going to copy this command. And I'm just in the temp directory. You can see here is my temp directory. Right now it's empty. Let's paste that command in. And we're just going to change where it dumps or creates the repository. So we're going to create a new repository in our temp directory. The name is just going to be module name, and organization, this would be your company name or your name, whichever. So just go ahead and run that, and we're done. So now we have a directory. Here's my repo name. You have all your typical things you expect to find in a Git repository. So you have your git ignore, we have our GitHub. If we actually look in the source directory, sorry, I know this is quite small, but here is my module name. This was the name of our module that we specified. And then here we have our PSM1 file, our PSD1 manifest, and our tests. Okay, so that was pretty easy. Who here thinks we're done? I could just commit this, and my module is available, and then we're good to go, right? Yeah, okay, you're all pretty smart. We're not done. So this is one way to do it. The reason we're not done is because if I want to publish something to the PowerShell module, I need that API key we talked about, right? I haven't entered that in anywhere. How does it know where to actually go publish our module? So let's take a look at the second method. So you don't need to do this if you wanted to just use that PowerShell module to create your GitHub repository or to create your repository. You could. One thing I'll note here is this is not initialized with Git yet, so you still need to run a git init on it to turn it into a Git project, and then you can upload it to wherever you want, Azure DevOps, GitHub, Bitbucket, wherever, right? Wherever you want to host this thing. So the alternative option for maybe people who aren't, who just don't want to, install yet another dependency, another module on their machine, is they can just copy the GitHub template. And so that's what these instructions here run through. It's essentially clone this template and then run this initialize repository.ps1 script. So let's go ahead and do that. Oops. I'm just going to switch to this tab. So here we are. It's still the same Git repository we were in. Oh, sorry. Where is public template? Sorry, there's normally, did they just change this on me? There's normally just a template button at the top where you say, I want to make a new repository. Oh, I know yes, I'm not signed in. Thank you. I missed the one thing on my setup instructions. Okay. Yes, so here's what I was looking for. Use this template, right? So I've marked this repository as a template, which adds this little button. It's just one checkbox in the settings if you want to make any of your repositories templates. So we're going to say create a new repository. I'm going to create it in my personal account. And sorry, 1 second. And we are just going to call it PS Summit 2024 test repo. I like long descriptive names. As you can tell, I'm not going to provide a description. We'll use it public and just create this. And so here I'm using the template, so I'm not forking it. When you fork it, basically it creates a relationship between the original repository and your new one so that you can sort of push changes back and forth between the two. When you use a template, you don't have that. I can't push changes back into my original repo where I copied this template from. It's basically just a static point-in-time snapshot of the repo. Okay, so here now we have our new repository we created, PS Summit 2024 test repo. If I go down, it looks exactly like the template repo we were just looking at. And so the next step is we want to clone this guy to our local machine. And we'll hop back into our temp folder. So here we have our new repository. Let's go ahead and open this in Visual Studio Code. Okay, and the next step on our list was just to run this initialize repository.ps1. Is that big enough? Can everyone read the text? You want it bigger? I'll bump it up one. Okay, so let's just go ahead and run this. And it's going to prompt me for the exact same parameters that we provided earlier, where it needs the module name and the organization name. So here, our module name, let's just call it PS Summit 2024 demo test. And I'm just going to put my name in for the organization. And if we look, so I should have had this open before, but basically what that did is it wiped out all the files in this repository and just set them back up the same way that this repo had been created. And so if I go look at my changes here, you'll see there's 36 changes. That's it, just deleting all of the template repo files and replacing them with the files just for this new module that we just created. And so if I look in our source directory, we now have a PS Summit 2024 demo test. And then here is our PSM1 file, PSD1. Okay, so let's go ahead and take a look at the README. And so that we don't have to look at the code, let's open the preview. So it says, hey, congratulations on setting up your repo, but you're not quite done. And this is what we were just talking about. So the next thing you need to do is go actually update the module files with whatever you want your module to do. Maybe you already had the PSM1 files are written. They were in some other repo, but you want to drop them into this template. You would just overwrite these files with what you have. The next step in the process is going and getting that PowerShell Gallery API key. And so if we click here, it gives us all the steps to do it. So it tells us, so let's just do that right now. We'll hop back over to Chrome. Here I'm already logged in, thankfully, to the PowerShell Gallery. And so I'm just going to say I want to create a new API key. You can call this whatever you want. I just provide a handy name that you could use if you like. I'm going to set it to expire in 1 day so that you guys aren't copying my API key and spamming me when you or trying to do something with it once the videos come out. And it's going to ask for the glob pattern. And so this will be all of the PowerShell modules that this API key is applicable to. So it's a good practice not to just put star, because then they could use that API key for any of the modules. You usually want to put the actual name of your module. So this API key is only applicable to this one module we are creating. Okay, so now I have a new API key. I'm just going to go ahead and copy that to my clipboard. We'll hop back to our instructions and continue following. So this is going to be set up in GitHub, so we're going to look at the GitHub instructions. It's basically just saying, hey, you got that API key. Let's actually go enter it into GitHub. So if we pop back over to our repository here, this is the new one that we just created, PS Summit 2024 test repo. We're going to go into the settings. Over on the left, we have our secrets and variables, actions, and we're going to create a new repository secret. Again, these steps are all listed in the README. I'm just glazing over it for the sake of time. So here is the secret that we got from the PowerShell Gallery. And if we hop over here, it says we need to call this secret PowerShell Gallery API key. This is just what the GitHub action workflows are expecting it to be called. Let's go ahead and add that secret. And if we keep going down in the instructions, it says, okay, the next thing we need to do is create an environment, and it needs to be called production. And this is just to enable approvals. So if we want to block deployments until specific people have approved, this is how we do it. So we're going to go into environments, create a new environment. It has to be called production, like the instructions say. So we hit configure environment. We want some required reviewers, and I'm going to type in my name, my username, so Deadly Dog. So now I'm a required approver on any deployments that happen to the production environment. All right, and there's one last step that we need to do, which is enabling read and write permissions so that our GitHub actions are able to add git tags with the version number. So over on the left here, we're going to go into actions, general. Down in the bottom, there's workflow permissions. Just change that to read and write. So now we have permissions to add git tags to the repository. Okay, now we're done. So that was maybe a little longer than 2 minutes like the title promised, but not much more, right? It's still pretty easy. So let's just go ahead and actually commit this. So initialized repo. So I haven't made any changes to this yet outside of running that initialization script, which was, as I mentioned, the same thing as just running this commandlet. So if we pop over to our repository, we can now go to the GitHub actions. And we can see it failed. That's not good. Okay, and spell check. So this has bitten me. Actually, let's just try this one more time, because I did not say initial commit. Did I not? Sorry. Oh, I did not push my changes up. That was the problem. I committed them, I did not sync them. Okay, so let's actually push them up to the repository. That would help. Okay, so initialized repo. Now our GitHub actions are going to start running. And this will just take a couple minutes. So while those are running, let's just go ahead and actually look at the repository it created. So we'll collapse everything. So you have a dev container, so you can use this PowerShell module with GitHub code spaces. It created some bug report issue templates for us. So when people file a new issue, it gives them questions that they have to answer and like specific steps to show us what PowerShell version you're using. So we have all the good information to help us debug their issue. Same sort of thing with feature requests and pull requests. So this template's sort of built in for all of those. In here are the workflows. These are the actual GitHub actions that are running. So you'll see that we have two. We have one for building and testing the PowerShell module, and one that does build, test, and deploy. And so the difference is the build and test is only run on pull requests, because we typically don't want to deploy pull requests out to a production, right? So it'll just build and test the PowerShell module, make sure everything looks good with it. When someone actually makes a commit to the main branch, that's when we want to do the deployment as well. And if we actually look at this, I'm not duplicating all of the logic in the build and test PowerShell module or workflow, I'm just calling it. Right? So any changes I make to this build and test one will automatically apply to the deployment one as well. So VS Code, there's some tasks. This allows us to do things like running all of the tests in our new module. So right now there's only one function, one test, and it runs successfully. And so speaking of that, yeah, let's go look at the module itself. So here's our PSM1 file. See, it says update me. This is just example code, replace the file contents. Right now we have a single function. All it does is spit out hello world. Similarly, we have the tests. They're all hooked up. They all work. But so yeah, once you update the functions, you'll want to add your tests for the new function. And then, of course, the manifest file as well, where you should come in here and update things like the description of your module, provide a link back to your GitHub repository so people can easily find it, find the documentation from the PowerShell gallery. And so one thing I just want to note here is you'll notice we have this tests file. We have a single test. But if I look in this deployment directory, we also have a file or a script called invoke smoke tests. And it actually just has the exact same test. And so just keep this in mind. I'm going to explain it more in a second. But you'll also notice it does not have .tests in the file name. So it does not automatically have pester ran against it. We have to do that manually. And then the rest of the files in here are just your standard like git ignore and everything like that. So let's hop back over to our repository. And it failed again. Let's see why. Failed to make the request. I think this might just be a network problem. It's my best guess. So let's actually just go ahead and rerun this. So this actually is a good opportunity to show the other thing it provides is when you want to change the version number, by default, every commit to main would just bump the patch number. So if you started with 1.0.0, the next version automatically would be 1.0.1, then 1.0.2. When you want to manually change it, you can just manually kick off the workflow. So let's just say it starts out with 0.1 is the default version. So let's just say we want to create version 0.2. One second. And I did create a different, oh, that's not what I wanted. I did create, ran through this all last night and had another one prepared in case we had issues like this. So let's open up that one. Okay, so let's just pretend that, that this one didn't have the network issue, that it had worked. This is what it would look like. So let's go look at our add spell check. So this one passed. So if we go actually look at our GitHub action, we can see everything that it's doing. So it's first checking out the code. We're just displaying the PowerShell version. So we can see the operating system that it's running on with the PowerShell version. We're doing spell check. We're installing git version, which is just used to determine the version number. And so here is where we know the stable version it's going to use, 0.1.0. And then here's the pre-release label that it would attach. So it is just basically a timestamp with the git commit SHA. From there, we run the PS script analyzer. We run all of our pester tests, generate a code coverage report. If there's a pull request, it'll actually attach that code coverage report to it. and then we create our module and deploy it and tag our version. Okay, so let's go back here. So you might have noticed, though, that's just the build step. And so if we're doing a pull request, this is the only step that would have actually ran. But because we're doing a deployment, it also kicks off these additional steps. So we have one here just for publishing our pre-release module. And then this one is kind of funky. And this is where that smoke tests file I told you to take note of comes into play. So here we have a stage called run the tests in the Windows PowerShell. And so if we actually look at this, it's downloading our smoke tests and running that invoke smoke tests file manually and ensuring that everything passes. And so the difference here is that when we're running the pester tests in the build, in this build and test step, it's basically just running them on, before the module has actually been compiled or built, it's running it on that one version of the agent. So it might be a Windows runner, it might be something else. But when we have all these additional steps, we have one for each operating system. So you can see I'm running our smoke tests on Ubuntu. I'm running the smoke tests on the latest version of Windows with PowerShell 7. I'm running the smoke tests on Mac OS. And I'm also running the smoke tests on Windows PowerShell 5.1. And so I don't know why more people don't do this. This has saved my bacon so many times in terms of backwards compatibility, where on my local machine, I'm developing in PowerShell 7.1. And so the tests all run fine for me, right? But I actually want my module to be able to run on Windows PowerShell. And so I might, a recent example I had was I was calling invoke REST method and providing the -retry parameter. So that's a super convenient parameter added in PowerShell 6 or 7. If the network request fails, it'll automatically retry, right? So I committed that, pushed it up, but I came back and the smoke test for Windows PowerShell failed because that retry parameter is not in PowerShell 5, right? And so if you want your PowerShell modules to work cross-platform as well, right? So maybe you have some of the organization uses Macs, and even though you're on Windows or whatever, by running these smoke tests on each of the different environments, you can have confidence that your module is going to work on all of them. Okay, so I just hopped back to our real repo that we made. Yay, it was just a network problem, so it succeeded, yay. And you can see, so it did publish our pre-release module. The smoke tests all passed. And you can see, though, now it's just waiting. It hasn't done anything. And this is because we set up that production environment and set myself as an approver on it. So now I can say I want to review the deployment, say, yes, I'm approving this to be deployed to production, click the button, and away it goes. So yeah, our module is actually there on the gallery. And if you don't believe me, let's take a look. So this is what we called it, PS Summit 2024 demo test, and it doesn't show up. Maybe you'll just have to take my word for it that it's there. It should be. Yeah, so here's the publish step that actually published it. Yeah, okay, I guess we just have to wait for the cache to refresh. In my rehearsals, it did show up within like a minute or two, so I guess it's just taking a little bit longer for this. Okay, but hopefully you can see how the smoke tests are really valuable to make sure you have backwards compatibility and cross-platform compatibility, and the approvals can be really valuable. Yes, that's a good question. So the question was, why do the smoke tests need to be a different file than the regular tests that we're running on build? And you might not want to run your full test suite, I guess, as a smoke test. You might want to only have your smoke tests run against things that are using sort of cross-platform compatible functions. That is actually a really good point, though. And I'm struggling to come up with a good reason why not to just run all the tests every time. They run quickly, or at least they should. So it shouldn't be an issue. So that's actually probably a change I will incorporate. But yeah, thank you. Okay, so let's just switch back to the slides, and I will quickly run through just the remaining ones. So I see we're just about out of time. Come on. Okay, so why use this template? You don't have to. There's other ones out there. I had looked, I had found a few. Unfortunately, most of them had zero documentation, so I didn't even bother looking at them. So let that be a lesson to you. If you are creating a module, you want other people to use it, provide documentation. Put a link back to the GitHub repo, because if people don't know how to use your module, they're not going to use it. There were some that I found that required using a different CI/CD system. They're a few years old, and I thought, well, why would I do that? I have my code in GitHub. Why not use GitHub Actions for the deployments? The two that I just learned about here while at the conference, so yay to the conference, learning new things, teaching us stuff. There's one called Stucco. I talked to another attendee. Both of us had the same problem where it just didn't work. We installed the module, tried to create a new repo. We were running into errors. It hasn't had a commit in 2 years. It has numerous issues and pull requests opened against it, so I don't know if it's actively maintained anymore. It was a super popular community one, though, from the looks of it, so I don't know if that's still the case. The other one, though, is PS module development. Fred presented this one yesterday. It's very similar to what I presented here. Like, I ended up building the same thing as him, but he's been developing his for years, so it's way more advanced and has a lot more capabilities. It can do deployments to Azure Functions and all sorts of things like that. But the caveat is, it's very opinionated. It also brings in a whole bunch of extra dependencies and things that you need to know about. So it uses Saki, Plaster, PowerShell build, all these extra modules, they need to be deployed on your machine. And if you want to make a change to the build system, you then need to learn those frameworks and understand those libraries. Whereas mine, it's just there's no extra modules at all. Yes, question?
Quick on the Stucco, I think what we were doing was using Stucco, but there's a fork of that.
There's PS Stucco.
Stucco, and that seemed to be working better.
Okay, I looked at that one too, but it only had like, I think 16 downloads or something. So I was like, it doesn't feel like a good one to. Okay, cool. So yeah, PS Stucco, you can try that. So definitely check those ones out. You don't have to use mine. Mine feels like I took the KISS strategy, like keep it simple, silly, because I didn't want to have to install all these extra things. And I was asking for a screwdriver. Something like PS module development is a Swiss Army knife, or yeah, where it can do so many things, but it might not be obvious because it can do so many things on just how to do the simple things you want to do. So I did have a few more slides, but we're running low on time, so I'm just going to skip right over them. And yeah, just so finally, like I said, it is an evolution automating your modules. The worst thing you can do is be typing stuff by hand and having to remember things. At the very least, make a checklist. Ideally, you have a script, and even better, use those scripts with your pipelines. And so the last thing I want to say is the two are not mutually exclusive. You can use scripts in your pipelines. It's just using pipelines also enforces a lot of best practices, like using source control, and it enables a lot of other things out of the box, like approvals and enhances security and that type of thing. So you want to use them together. And so with that, I will say thank you very much.